Directions. Read the text or watch the video or listen to the recording to have the text and questions read to you and answer the questions that follow. Bolts from the Sky by Conrad Storad from chainreactionkids.org. Lightning is actually static electricity. Static electricity is very much like the sparks you get when you walk across the carpet and touching something. However, nature creates much more static electricity than all the rugs and carpets in the world combined. Lightning forms when rain falls through clouds. As rain droplets fall, they tug electrons down through the clouds with them. Electrons are the tiny parts of an atom that have negative electrical charges. Nature likes to maintain a balance, so when electrons get pulled out of place, nature wants to put them back. That's exactly what lightning does. Raindrops pull down electrons, but their proton partners get left behind in the upper part of a cloud. Protons are the tiny parts of an atom with a positive electrical charge. Protons and electrons are attracted to one another just like magnets. Lightning occurs when lonely electrons seek out nearby protons to recreate balance. Those protons might be resting at the top of another cloud. They can also form along the ground under the cloud. When protons are pulled from another cloud, the result you see is a cloud-to-cloud lightning. But when the protons are pulling up from somewhere on the ground, the result is a lightning strike. Well, not really. Lightning does not actually strike the ground. It stops about 50 feet above the ground. When downward flowing electrons meet upward flowing protons, they complete an electrical circuit. That circuit is much like the connection that forms when you plug in a CD player to an electric outlet and turn on the switch. Lightning is actually a gigantic flow of electrons through the circuit that is completed in the air. On the ground, the protons closest to the downward flowing electrons will be pulled upward to complete the circuit. Those protons might be part of a tree or part of a person standing in the middle of a golf course fairway. Protons are drawn upward from the highest point closest to the electrons. That is why a person should never stand in a field or hide beneath a tree during a thunderstorm. If you are at the highest point closest to the flowing electrons in search of a positive partners, the protons inside your bodies will begin to flow upward. Your hair, which contains protons, would stand straight up on end as those protons reach skyward. About 50 microseconds late, before you could even blink your eye, the circuit would be complete and you would be electrocuted. Question 1. What inference can be made from bolts from the sky? 1. Lightning is very quick to strike but won't hurt you. Lightning is very dangerous and you should stay inside during a storm. Lightning can be fun to watch during a thunderstorm. Lightning is like electricity that we use in our homes. Question 2. What detail from the passage helps support your answer for number 1? Protons and electrons are attracted to one another. Lightning occurs when lonely electrons seek out nearby protons. Lightning does not actually strike the ground. The circuit would be completed and you would be electrocuted. What is an atmosphere? By Conrad Storad, chainreactionkids.org. Atmosphere is the huge blanket of gas that circles the entire Earth. Without it, life as we know it could not exist. This blanket of gas starts at ground level and stretches 600 miles into the sky. However, most of this life-supporting shell is squashed down into a layer only 6 miles thick. The top of Mount Everest is barely peaks above the edge of this layer. The remaining 594 miles cannot support life. However, these layers do protect us from the dangers of the sun's radiation. They also protect us from drifting rocks, huge hunks of metal, and other bits and pieces of space junk that collide with our planet from time to time. The atmosphere is made up of four different layers. Layer number one is called the troposphere. Purple plants, sorry, people, plants, animals, and insects live in the troposphere. It is the layer where all weather occurs. Scientists who study weather are called meteorologists. They refer to the troposphere as the weather zone. The troposphere begins at ground level and extends 6 miles up into the sky where it meets the second layer. Layer number two is called the stratosphere. The stratosphere begins at the 6 mile point and reaches nearly 31 miles into the sky. A very important layer of atmosphere called the ozone is located inside the stratosphere. The ozone layer is very important to all life on Earth. Ozone blocks large amount of solar ultraviolet radiation from entering the troposphere. Too much solar radiation can harm living things, including people. The third major layer is the mesosphere. The mesosphere begins 32 miles above the Earth's surface. Temperatures are warmest at the lowest level of the mesosphere and become colder at its highest level. The thermosphere is the fourth layer and begins 50 miles above the Earth. Temperatures in the thermosphere become hotter and hotter when moving further away from the ground level. Together, the troposphere, stratosphere, mesosphere, and thermosphere acts as a giant safety blanket. They keep the temperature on Earth's surface from dipping into extreme icy cold that would freeze everything solid, or from soaring to blazing heat that would burn up all of life. Question 3. What inference can you make from what is atmosphere? The atmosphere is 600 miles wide. The mesosphere is the warmest layer of the atmosphere. The troposphere is called the weather zone. The atmosphere is very important to the planet Earth. Question 4. What detail from the passage helps support your answer from question number 3? People, plants, animals, and insects live in the troposphere. A very important layer of atmosphere called the ozone is located inside the stratosphere. The atmosphere acts like a huge safety blanket for planet Earth. Without it, life as we know it could not exist. Too much solar radiation can harm living things, including people. Question 5. Based on the information in the text, what other inference can be made that the atmosphere is important to planet Earth? The atmospheric layers protect us from the sun's radiation, drifting rocks, and pieces of space junk. People, plants, and animals live in the troposphere. Meteorologists are scientists who study the weather in the troposphere. The troposphere becomes hotter and hotter when moving further away from ground level.